everyone, this is video 6 for lesson number 3, metals and non-metals. In the previous video, we have studied about the ionic compounds. Now, you all know that ionic compounds are made up of oppositely charged ions, that is, cations and anions. And between them, there is a strong electrostatic force of attraction, due to which they are known as ionic compounds because they have ionic bonds or electrovalent bonds between them. These ions influence the properties of these compounds. So, we will discuss the properties one by one for ionic compounds. First, if we talk about the physical state, ionic compounds are generally solids which have the crystals. In these crystals, the ions have strong attractive forces, and therefore, due to this force, they have a hard structure. Okay, and along with the hard structure, they may have luster also. The crystal and luster differ in their shape and luster shine. Okay, the difference is due to the arrangement of ions. The arrangement of ions is different, therefore the hardness will vary from one ionic compound to another ionic compound. And this arrangement of the ions in the space is called crystal lattice. Okay, if you see the structure of NaCl, NaCl is a three-dimensional cubic structure. And you can see the blue and green, these are Na plus and Cl minus ions. They are held together very closely with a very strong force of attraction. Therefore, they exist as hard solids. Okay. Next, we come to melting and boiling points. As you know that ionic compounds have strong force of attraction and therefore they require more heat for melting and boiling points, because there is a strong force which is holding both the cations and anions together. Okay, you can see here there is strong electrostatic force, plus minus, they are so closely imbibed that more amount of heat is required for melting them and also to boil them. Here is a list of some ionic compounds where you can see the melting and boiling points. The temperatures are given in Kelvin. You can see the values. All the values are above 800 Kelvin. So much heat is required as they have a strong electrostatic force of attraction between the ions. Now, when we are providing the heat, then what will happen? The ionic substance will melt and that crystalline structure will be broken. And this state is known as molten state. This we will study in the next part of the slide also. So you should know what is the difference between a solid and a molten state. Molten means the crystalline structure has been broken due to heat. Now the ions are free to move. Ions have lost that force of attraction which was between them, and now they are free to move. The free ions during melting, why? Because the bond has been broken. Okay, and just we concluded that ionic compounds have high melting and boiling points. One more thing I would like to tell you here, that ionic compounds exist as a network in which oppositely charged anions and cations are closely packed, and each cation is surrounded by a number of anions, or it can be vice versa, but they do not ever exist as a single molecule like hydrogen, oxygen, nitrogen, etc. These all are not ionic compounds. Ionic compounds means it should have one cation and one anion always. Okay. Let's see the next property, solubility. Ionic compounds or electrovalent compounds are mostly soluble in water because water helps in the separation of oppositely charged ions from these compounds, and this process is known as dissociation. Okay, let's see how dissociation takes place. You can see here the crystal of salt. It can be any salt. It will have a plus cation and minus, anion will be there. So what water does here is that water surrounds each of the plus and the minus ion. Okay, how? In this way. Suppose this is the minus charge of the salt, it will be surrounded by water like this way. H will have a positive charge, so again they will have a strong force of attraction between them. And what will happen to plus positive part of the salt? It will be surrounded in this way. O near and H here, because O will have a negative charge, and in this way both positive and negative part of the salt can be separated. Okay, water molecules, they form a cover around these ions, and then they are said to be hydrated molecules. Okay, they are said hydrated by why? Because molecules of water have changed them, and therefore they change to hydrated ions. Why? Because they have split into cation and anion, and this happens only when they dissolve in water. So ionic compounds, they are soluble in water. Next property is electrical conductivity. The ionic compounds are good conductors of heat and electricity. Why? Because they are carrying the charged particles. They have ions with them. Therefore, they are good conductors. But the thing that should be learnt here is that for the charge to move, the ionic mobility is required. Means the ions can move. Okay, and ions can only move in molten state. They cannot move in a solid state. That's why I told you there, learn about this molten term also. Okay, ionic compounds, they have charged ions, correct, but they can conduct electricity only when the ions will move. A solid crystal of any of the ionic compound will not conduct electricity. The electricity will be conducted in two states. Either it is in molten state, it has been heated up to melt, or it has been dissolved in water so that the ions can dissociate. In both the two states, the ions will be free and then they will move and thus help in the conduction of electricity. You can see in this activity, this is the setup for showing electrical conductivity. Here the sample contained distilled water. It is not a conductor of electricity. It is not an electrolyte. Therefore, the bulb is not glowing. Here what is happening? The ions are fixed into a solid. The sample that has been taken, it's a solid salt. So here also the bulb is not glowing, because for conduction of electricity, the ions should be mobile. They should be in the free state, then only electricity will be conducted. In the third C part, you can see the solution is having positive and negative ions, which will be free. They will move, and thus you can see the bulb is glowing because it conducts electricity in the molten or in solution state only. Okay, so this topic covers your chapter lesson number 3. Thank you.